Hello everyone, and welcome back to the channel. So today we're diving into a powerful Python project that tackles one of the most important questions in early retirement planning, and that is, will your portfolio survive 30 years of retirement? We're going to build a Monte Carlo simulation that models thousands of possible market outcomes, and this will be based on realistic asset allocations, returns, and volatility. So this isn't just a calculator, it's a stress test for your FIRE strategy. And FIRE meaning financial independence, retire early. So we'll walk through the code, visualize the results, and calculate your success rate so you can make smarter decisions about how much you need to retire early and stay retired. So let's get started. All right. I'm currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it easy to get started programming in Python. So if you want to code along with me, just go to this website and then log in with your Google account to get started writing your Python code. All right, so let's get started writing this code. We're going to first click on File, then click on New Notebook and Drive. This will open up a new tab for us, and it will also open up a new cell for us. And this is where we're going to start programming. So the first thing that I'm going to do is import the libraries that we will need. So I'm going to import numpy as np, and this will be used for numerical operations. And then I'm going to import matplotlib.pyplot as plt, and this will be used for plotting graphs. So I'm going to run this cell by clicking this button here to the left, and this will let me know if I made any mistakes, and it will also run the cell. All right, so it looks good. We get a little check mark. Let's create a new cell by clicking that code button in the top left. All right, so now what we're going to do is we're going to create a few parameters for our portfolio. So here I will create some parameters for the FIRE portfolio. All right, so I'm going to create a variable called initial underscore portfolio underscore value. So we're going to give this portfolio a initial value of $1 million. So that's 1_000 underscore 000. Okay. So this is the starting value of the retirement portfolio. Okay. So next, let's go ahead and let's get the withdrawal rate per year. So I'm going to create a variable called withdrawal underscore rate. And I'm going to set this equal to 0.04. So that means that we're going to be withdrawing 4%. And I'll go ahead and put some comments here. Just put withdrawal rate per year. And then we'll put, for example, 4% here. All right. Okay, so next we want to get the amount withdrawn from the portfolio each year during retirement. So this will be the annual spending. So I'm going to create a variable called annual spending. I'm going to set it equal to, it's going to be equal to our initial portfolio value times our withdrawal rate. Okay, so again, we're going to be taking out 4% each year. So 4% of $1 million is $40,000. So our annual spending in this case would be $40,000 based off of these parameters. Okay, and so again, this is the amount withdrawn from the portfolio. All right, and then we're going to create a variable called years. So this is the total number of retirement years that we're going to simulate. And like I said earlier, we're going to do 30 years. And of course, because this is a parameter, you can make it whatever number you want to, right? So we're going to do 30 here for this example. We're doing 4% for the withdrawal rate, and we're getting a initial portfolio value of $1 million. And then let's create a variable called simulations. We're going to set this equal to 1,000. So this will be the number of Monte Carlo simulations to run. All right, so 1,000 is pretty good. You can do more if you want to as well. All right, let's go ahead and run this cell. Now that we have our parameters all set, we're going to create a new cell using that code button again. And now we're going to create the asset, allocations and assumptions. All right, so we're going to have a portfolio, right? So we're going to need some weights. So how much or what percentage of assets are in the portfolio, right? So like, is it 60% stocks? Is it 80% stocks? Is it 50% bonds? Is it 100% cash? So things like that, right? So we're going to create here, we're going to put our assets. One will be stocks, and we're going to say that this is, we'll do 60% of our portfolio. So here I'm just going to type 60% of the portfolio is invested in stocks. All right. And I think I need to put a comma right here. Okay. All right. So let's tab on over. And I like what Google has suggested here. I'm just going to tab over here. So, oh, and it created this extra curly brace. Let's get rid of that. All right, so next we have bonds, we have cash. So here put 20% for bonds. Actually, I'm going to do 30%. So let's say the portfolio is 30% bonds, and that means I need to adjust this number down here as well. So we're going to do 10% cash. All right, so we have a total of 100% for our portfolio in stocks, bonds, and cash. All right, so I think that looks good. And here I put some comments. I just put defining the weight, or how about this, defining how the portfolio is split among different asset classes. Okay. All right. So that's good. Let's define the expected average annual return, and I'll bring this up. There we go. Let's define the expected average annual return for each asset class. So I'm going to create a variable called returns, and we'll have, just like Google suggested here, stocks, bonds, cash all over again. So I'm just going to tap over. Let's get rid of this extra curly brace. Okay, so here for stocks, I believe the S&P 500 has returned something like 10%. But anyways, we're going to use 8% here for now. So we'll do 8%. 8% expected returns on stocks. So bonds would do 3%. So 3% expected return on bonds. And that 10% is from a specific time period that I'm thinking for the S&P 500, but I can't remember right now. So make sure you do your own research. All right, and so we're gonna also do cash. We're gonna say cash returns 1%. Okay. So 1% expected return on cash. And I believe you can find high yields for cash as well that return greater than 1%, but this is fine for now. I think that looks good. All right, I think this is a good time for me to say that this is not financial advice, and to do your own research before making any sort of investment. All right. All right, so with that being said, let's continue. So next I want to define the annual volatility. Volatility. Okay, so this is just the standard deviation, right, for each asset class. So I'm going to bring this up a little bit. Let's create a variable called volatility, and let's set this equal to what Google put there. Maybe let's just tab over. All right. So Google has stocks, bonds, cash again, and stocks, we just put 15% volatility on stocks. We'll do five. Oh, that's 50. Let's do 5% volatility for bonds, and for cash, yeah, maybe a 1% volatility. Okay. All right. So I think this looks good. Let's go ahead and run this cell. Let's create a new one, and oh, All right. So let's now create our Monte Carlo simulation. So here I put in comments, Monte Carlo simulation. All right. So let's create a function. We will call it, I like simulate portfolio. We'll call it simulate underscore fire. All right. So let's see. The first thing that we want to do is probably create a empty list to store the portfolio value history for each simulation. So I'm going to create a variable called all underscore simulations. So this will be an empty list that will store all of the simulations. Okay. And let's put that in some comments here. So list to store the portfolio value history for each simulation. All right. So now let's go ahead and let's loop through every simulation. So remember, we have 1,000 simulations, right? That's the variable that we created up here, simulations. So let's loop through all of the simulations. So we can say for I in range simulations, we're going to do something. We really don't need this variable I right now, so I'm just going to put an underscore. All right. So let's see. We are going to repeat this 1,000 times, and we need to start each simulation with the initial portfolio value. So let's create a variable called balance, and let's set it equal to the initial portfolio value, just like Google suggested here. I'm just going to tap over. All right. And now let's see, we're going to, well, we need a list to kind of store the portfolio value for each year in the simulation. So let's just call it, I like what Google put here, portfolio history. I'm just going to tap over. Okay, so list to store the portfolio value history. I like that. We're going to make this a empty list for now. All right. And let's create another loop. So it's a loop within a loop. So for I in the range of years, right? Because we want each simulation to go for, in this case, 30 years. So that's what we defined up here. So years equals 30. So for I in range years, we're going to do something. And I don't think I'm going to need I. So I'm just going to put underscore here. And let's press enter. So now we're going to simulate each year of retirement. And maybe I'll put that here. Simulate each year of retirement. And maybe here I'll put repeat the simulation times. Okay. All right, let's tab that on over. Okay, so here I want to initialize the annual return for this year. So annual underscore return is going to be 0 for now. So we're just initializing the annual return for this year. Okay. All right, next I want to calculate, and I'll put that in comments here. Calculate the weighted return based on each asset's random performance, right? So this is what makes it, a Monte Carlo simulation. So let's see what Google put here for asset, comma, weight and weight items. Okay, I like that. We're gonna say for asset and weights, we're going to create a variable called asset return, and we're going to set this equal to np.random.normal. I like that as well. I'm going to tab over, all right, and then just kind of explain what's happening here. So here we're just simulating the asset returns, using normal distribution. Okay. Let's go back on over. So that looks good there. So we have our random performance. And then here, Google created a variable called annual underscore return. And it set it equal to annual return. Let me see here. Set it to annual return plus weights of the asset times the asset return. Okay, that works. All right, and also let me go up here. So returns, you can see we have asset right here, right? So what will asset be? Well, asset's going to be either stocks, bonds, or cash. So that's what asset will be, and returns is obviously here, right? So we're going to look into returns and then stocks, and then we're going to get that value here, and then look at returns bonds and look at this value here, or get that value there, and same for returns in cash, so on and so forth. And the same thing for volatility. We're going to go through volatility, get stocks, get bonds, get cash, get that value, right? So again, this will be the asset, and then we're going to be getting that value. All right, so I just wanted to kind of make that clear. Also, this calculation seems correct here. And let's continue. Okay, so let's get out of that loop. And I want to, well, first I want to actually put a comment here. So here we are adding the weighted return to the total annual return. All right, so let's come down here and let's add another comment. And here we're going to update the portfolio, or the portfolio value, after applying the return, and we need to subtract what we're spending. So subtracting spending. Okay, so I'm going to create a variable called balance, just like Google has here. And I'm going to set it equal to balance times 1 plus annual return. Oh, we can do that, minus annual return. I'm just going to tab over. All right, so that looks good right here. We're applying the growth from the investment returns and subtracting the annual spending. All right, so that looks good. Let's create a variable called portfolio. I'm sorry, not create. Let's use our portfolio history variable that we created further up here. Right, it was an empty list. And guess what we're going to do with this empty list? Now we're going to append to this empty list. And what are we going to append? We're going to append the balance. All right, so this right here allows us to record, and I'll make that a capital R, record the portfolio value for this year. Okay. All right, now let's do some checks. So if balance is less than or equal to 0, then we're going to break. So if the portfolio is depleted, we're going to stop the simulation early. All right. So I think that looks good. And let's go out one more, I believe. Yep. So we're under there. Okay. So now I want to store the result of this simulation. So we're going to take the list that we created before the first for loop, which was called all simulations, and we're going to append the portfolio history to this. All right, so I'm just going to tab over, and Google suggested or did everything for us really, and it's going to return all simulations. So here we're just recording the portfolio value history for this simulation. All right, for this, yeah, for this simulation. All right, so that looks good. I think that's it for this function. I'm hoping that it works. So let's go ahead and run this. Let's create a new cell. And now what I want to do is I want to I want to calculate the success. So calculate the rate of success, or maybe I should say calculate the success rate, right? So how many portfolios lasted for 30 years in this case? All right, so first I'm going to initialize a counter for successful simulations. And those are all the simulations that were not zero. So I like what Google put here. It put successful underscore simulations instead of equal to 0. That works. And you know what? Actually, I'm going to call it successful count. All right. But successful simulation also would work as well. All right. So next we want to loop through each simulation or each simulated path. All right. So for path in simulated underscore and simulated underscore paths. Now I need to actually create that. So let me go up one. Let me create a new cell here. Go up. And let's run the simulation and store the results. All right, so I'm going to create a variable called simulated underscore paths and set it equal to our simulate F.I.R.E function, which was this whole function that we just created right here, that Monte Carlo simulation. All right, so now I'm going to run this, and now we have all of those paths here in our variable called simulated paths. And now I can go through each simulated path. All right. Otherwise, yeah, we're good here. I think that's good. So we could, I suppose, just use the function, but we're going to go with this. We're going to use this simulated paths variable, and we're going to go through each path. All right. So let's check if the simulation lasted all retirement years. All right, and ended with money left. So even if there's at least $1 left, then it's a success. All right, it lasted for 30 years. All right, so if the length of the path is, all right, let me see, if the length of the path equals years and path -1 is greater than 0, then successful count plus equals 1. I like that. Let me just tab over for now. Let's escape out of here. All right. So if that last path, if that value for the last path is greater than 0, then it was a success, right? So anything greater than 0 is a success. And then we set our counter plus equal 1, so we increment our counter by 1 here, which is called successful count. All right, and then here, let's see, calculate the success rate as a percentage. That is very, very nice. I like it. So it created a variable called success rate, and we get the successful count divided by the number of simulations, right? So if every simulation got a, if every simulation went here to this line of code, the successful count would equal the number of simulations, right? Because we're going through the simulated paths. All right. So we can also, instead of put simulations here, maybe it's better to put length of simulated paths. All right. Okay, so we're going to get that rate is multiplying it by 100 here. And I'm trying to think, do I want that? Maybe not here just yet. Maybe we'll hold off on that. All right. So let's go ahead and print the success rate like Google was about to do, it looks like. So we're going to put F here and then success rate. I'm just going to just tab over. So success rate, and then we're going to have success rate here times 100.2 F percentage. That'll work. And then 100. point to F. Okay. Or I think I can also do, I think I can also do this right here where I just do point to percentage. I think that'll work. All right. And then of simulations lasted I'm gonna do curly brackets years and then put years here and then a period. So hopefully that works. Let's run it. Let's see what it looks like. Oh, right. So we don't need this percentage here. All right, so let's just run this. All right, so now we get success rate 98.3% of simulations lasted 30 years. That's pretty good. Let's create a new cell, and in this cell, we are going to actually visualize the data. So visualize the data. All right. Okay. So let's create a plot. So we're going to type PLT, this from matplotlib. So PLT.figure, and we're going to give our figure a figure size. So type fig size, and we'll set it equal to 10 by 6. I don't like that. Let's do 12 by 6. Okay. And next, let's go ahead and plot the simulated paths. And actually, I want to plot the, we'll plot the first 100 simulated paths, or plot, how about this, just plot 100 simulated paths. Okay, I think 1,000 just doesn't look that great. So for path and simulated paths to 100, again, if you want to do all 1,000, you can just put a 0 here to do 1,000. We're going to do plt.plot path and then set alpha equal to 0.5. You know, I do 0.3. And let's draw a horizontal line at 0 to indicate bankruptcy. So I'm going to type plt.xh line. Again, we're going to put the xh line at 0. The color will be red. Okay, and we're going to give it a line style. So line style will be a dotted line. So we're gonna have a dotted line in our chart, and then the label will be bankruptcy. Hopefully I'm spelling that correctly. And then threshold. All right. And again, this is just drawing a line at 0 to indicate bankruptcy. Okay. All right, so next, let's go ahead and add the title and axis labels. So type plt.title. Let's go back here. There we go. All right, so I'm gonna call this Monte Carlo simulation of, I like that. I'm gonna do, yep, F.I.R.E portfolio and tab on over. All right, and then PLTX label will be years. We'll put years into retirement. And then plt.y label will be portfolio value. Let's put a little $ here so we know it's in USD. And then we're gonna have a legend, so type plt.legend here, which is good. And we're gonna show the plot, so plt.show, that looks good. All right, so also we're going to type plt.type underscore layout. All right, and hopefully that'll do it. So let's go ahead and run this and let's see what it looks like. Come on down here and let's zoom out a little bit. Okay, so this is what it looks like. So we have 100 portfolios being simulated here. we can see one portfolio did really, really well. It looks like it's an outlier, really. And they have all these the other 99 portfolios here. All right, let's take a look and see what it looks like with 1,000. I'm gonna run this. I just added or appended a 0 here. Yeah, I don't like that, but here are all the simulations. This is what they kind of look like. So I'm gonna put it back at 100. But we can see the success rate again was 98.3%, which is pretty good for 30 years. And so what does all this tell us, right? So this tells us, using this Monte Carlo simulation, that if we had a portfolio value of $1,000,000 and we withdrew 4% or $40,000 a year for 30 years, given these 1,000 simulations, then the portfolio would survive 98.3% of the time for those 30 years, which is pretty good. All right. And this kind of coincides with the 4% rule. All right. So thank you all. That's a wrap. You've just built a FIRE simulation that doesn't just crunch numbers, it models reality. You can get this code and many others on my Patreon at patreon.com/computerscience. And with Monte Carlo simulation, you're not relying on perfect market conditions. You're testing your retirement strategy against thousands of possible futures and getting a real success rate you can use to adjust your plan. So if you found this helpful, be sure to like, subscribe, and hit that bell icon so you never miss another video or tool or program that helps you take control of your financial future. Again, not financial advice. Please check my code. Please do your own research, and I will leave some links in the description below about the 4% rule so you can read more about that as well. So thank you all. And I also will say that I will also leave a link to the Patreon page in the description below, which again is patreon.com/computerscience. So thank you all. I hope you enjoyed, and I'll see you all in the next video. Bye-bye.